Hi, today I will be speaking about the three different plate movement types found on Earth. I'll be going a little bit in depth about each of the three different movement types, and I will also be going in depth using an example or a well-known location on found on Earth that demonstrates each of the three different plate movement types. So the first type of movement is a divergent boundary or a plate divergence. And as you can see by the diagram, a divergent plate boundary, um, is when two plates just move away from each other, and it causes a rift or a tear within a major plate. And these are often marked by new crust rising or shallow earthquakes and volcanic activity happening. Even underwater, you can still find earthquakes and volcanic activity within tears in the earth when a plate divergence occurs. So, a well known example of this would be the Mid Atlantic Ridge. Not a great photo there, but the Mid Atlantic Ridge is, as you can tell by the name, is located along the Atlantic Ocean floor, and it's actually a part of the largest mountain range in the world, even though it is located underwater. So, the Mid Atlantic Ridge separates the North American from the Eurasian plate and the African plate, and it is thought to be caused by upward convective forces in the asthenosphere pushing the oceanic crust and the lithosphere. So, coming back to the diagram, you can see the asthenosphere is the bottom layer here underneath the oceanic crust and the lithosphere. So, it is thought that pressure or forces in this layer of the Earth causes the plates above it to move apart from one another and create the tear that causes things like the Mid Atlantic Ridge. And the Mid Atlantic Ridge has a average spreading rate of about 2.5 centimeters per year, which literally means that every year the gap in the ridge just gets bigger by 2.5 centimeters. So the second type of plate movement would be a transform boundary. So a transform boundary, as you can see in the diagram here, is when two plates move past one another laterally. So they're moving opposite directions, but they're still touching and moving along each other instead of moving away. They basically rub up against one another. And they are along great fractured called transform faults. So, a very famous example of that would be the San Andreas Fault. And the San Andreas Fault is a continental right lateral strike slip transform fault. And it is roughly 1,200 kilometers, which is about 750 miles long, and it runs through the state of California. The San Andreas Fault Line forms a tectonic boundary between the Pacific Plate and the North American Plate. This just means that the Pacific Plate and the North American Plate are the two plates that are moving laterally past one another. So the San Andreas Fault is actually so large that scientists break it up or classify it into three main segments. The three segments are the northern segment, central, and southern segments. And they do this because each of the three different segments have different characteristics, and they all also have different degrees of earthquake risk. So by breaking it up into three sections, it's easier to predict how much earthquake activity can happen in a location based on which segment of the fault you're located in, because all of the three different segments have different degrees of earthquake activity, which just means how likely you are to get an earthquake and how large of a earthquake you will get in each of the segments. So the San Andreas fault line also has an average slip rate along the fault of 20 to 35 millimeters per year, which just means that the two plates move past each other at a rate of 20 to 35 millimeters per year, and that is transform boundary. So the third and final plate movement type is a convergent boundary, or a plate convergence. And this is just when two plates collide. And as you can see by the diagram, one plate will go underneath or subduct the other plate. The denser plate, usually the crust, will go underneath the lighter one, and that is when mountains are formed or occur. And there are three main types of convergence. There's oceanic continental, there's oceanic, and then there's continental. And you can probably tell by the name of the different types. Oceanic occurs with two plates that are in the ocean or underwater. Continental is with two plates that are on Earth or above water. And oceanic continental is when one continental plate converges with an oceanic plate, and that's usually along the coast, where like oceans are, beaches, and mountain areas, when those two landmarks or landforms meet. So a well-known example of that is the Himalayan mountains. So the Himalayan mountains separates the plains of the Indian subcontinent and the Tibetan plateau, and it's just basically a collision of the India plate and the Eurasian plate. The Indian tectonic plate goes underneath the Eurasian plate. It subducts it, and that creates the mountains in the mountain range of the Himalayas. And yeah, that is the three different plate types.